Hello, Jonathan Bisnet here, and I have another circuit to show you today. This one is based largely on one I did previously with dual 7-segment displays with multiplexed inputs. In this particular case, I've actually used two of those displays together to give us a 4-bit output pattern. And what I've really done is treated this board here as a programmable output display, and I'm driving it using an Arduino Micro here. The way this works is that, and you'll see that the pattern, different patterns flicker across the display. It uses the display in various manners, but basically the way this works is it's centered off of a 555 timer chip right here in the middle. This chip actually puts out a cycle of roughly 68 hertz, and it drives these two buffer chips, 274 HCT 373 chips, one here, and basically alternates enabling the output from each of these chips. And what happens is when the chip is enabled, it outputs to the left 2, then the right 2, then the left 2, then the right 2 in that fashion. The values that it outputs are actually stored in these 7475 chips. There's 4 of them here. Each of them is a 4-bit latch, and they hold the 4 bits to be output to the display. And when the three set, basically the values from these chips are automatically enabled on the inputs to the buffers. So the buffers take whatever is stored in these chips and put it and store it locally. And then based on the enable, they send their information up to a 7447 7-segment decoder. And there's one on each side here, each driving one of the two displays. And over here in this corner, what you'll actually see is this is a hex inverter, and this is a 74LS139, which is a 1 to 4 decoder to multiplexer. So the way this circuit actually works is that the Arduino, basically these first 4 wires here, provide the 4 bits that that represent the digit I want to display. The next 2 wires represent the address, so basically 0, 1, 2, 3 being the address of the display element. And then finally this green wire, this last one, it's actually dark, goes up here to the decoder, and it becomes the strobe or the pulse that tells the decoder to output a clock signal to one of the 4 7475s and lock in the value, whichever one is selected by the address. Once that's done, oh, and I'm sorry, this last one here, this one here is just simply a common ground between the two systems. So then, once the strobe comes in here, most of the outputs of this are actually sent through the hex inverter because of the signal that's required by the chips, the 7475s. But then it comes out of there, and then into these individual 4 chips. These 4 bits that are coming from the Arduino are actually wired to all 4 of the 7475s with some final 15k ohm pull-down resistors on the end of the line. So all 4 of them see the same 4 bits, just depending on which one the encoder has enabled, that one will latch in the value. And then the values are presented to the buffer chips, and the 555 timer basically enables them in alternating fashion, feeding the appropriate 4 bits to the decoder and driving the display. And that's really the basis of what's going on here. So just to give you kind of a little closer picture of the actual circuit, and this of course over here is just basically a 5-volt power supply. And then you'll see down here the different chips we have across here. There's the little 555 timer hidden in the middle there. And then just the standard wires to the Arduino. fairly simple circuit. Looks like a lot of chips and a lot of stuff going on, but it's actually not very complicated in its nature. Anyway, I thought I would go ahead and show that to you. As for one final thought, the Arduino, the code that's running in there was really very simple to write. It simply outputs, it either puts a pin high or low for the individual 4 bits that drive the digit, and again, same high or low for the address bits. And then finally for the pulse bit, it sets the pin high, sets the pin low almost instantly to create that pulsed effect to let the circuitry know that the data on the outputs or on the inputs is valid. So anyway, that's the circuit. I hope you found it interesting, and thank you.